We can take things a step further now by utilizing the second law, Faraday's second law, to not just figure out the charge that's flowing through a circuit, but also figure out how many moles of a substance is produced at an electrode. In order to do that, we have a few steps that we have to follow. Okay? Let's write them in red. Steps to follow. Our first step is going to be to find the charge. So whenever we want to figure out how much of a substance is produced at an electrode, we have to find the charge in coulombs. After we do that, then we have to convert our coulombs to a new unit. That new unit is called Faradays, after the man himself. If you have two laws, why not have a unit as well? Okay? And it's a standard conversion factor. 1 Faraday is equal to 96,500 coulombs. Alright, so that's one of the constants in chemistry that you will most likely get within your question. But if you don't get it, you know that 1 Faraday is going to be equal to 96,500 coulombs. Alright, once you convert your charge in coulombs to Faradays, then you're going to make use of Faraday's second law. So we're going to use Faraday's second law. And when we use Faraday's second law, what that second law essentially says is that if you have an atom, if you have an ion rather, and it is gaining a mole of electrons to form a neutral atom, so you have an ion and it's gaining 1 mole of electrons to form a neutral atom, the charge on 1 mole of electrons is essentially equal to the charge of 1 Faraday. If you have a divalent ion and is gaining or losing 2 moles of electrons to form a neutral atom, then the charge on 2 moles of electrons is equivalent to 2 Faradays. So I'm paraphrasing. This is how I always explain it to my students. When you look at the half equation, because the wording of the second law is kind of funny, you can look at it in your handout. When you look at the number of moles of electrons in your half equation, you can replace that with Faradays. So what this equation is telling you is that 1 mole of B2 plus ions reacts with 2 moles of electrons to give you 1 mole of B. If we utilize the second law, what it tells us is that 1 mole of B2 plus ions gains 2 Faradays of charge to produce 1 mole of B. So you set up an equation between Faradays and the number of moles of the product that you want. And once you have the connection between Faradays and the number of moles of the substance that you want, then you can use moles to find out anything. You can use moles to find out mass. You can use moles to find out volume if it's a gas as well. So the easiest way for us to understand and appreciate this is with a question. Okay, so we're going to work through a question step by step, and hopefully that will make everything be a little bit clearer. All right, so we're going to say, what is the mass of copper formed at the cathode during the electrolysis of molten copper 2 chloride using inert electrodes. Remember your inert electrodes, graphite or platinum electrodes. If, and just to make life easy, we're going to use our current and time from the question above. So if 5 amp of current flow for 30 minutes, okay, and then you know your relative atomic mass of copper is 64 grams per mole. Okay, so that's our question. That's what we are tasked with finding out. We want to find out the mass of copper that's formed at the cathode during the electrolysis of molten copper 2 chloride. Now, this question could also have several previous parts where you could be asked about what is happening during the electrolysis, what would you expect to see, half equations that you're going to have to write, and all that type of stuff. Alright, so let's go through, let's attack our question. So, first thing we have to do is we're going to have to find the charge. Find the charge. So, we're using our Q is equal to I times T. I is 5 amps. The time is 30 times 60. So, our charge is 9,000 coulombs. Alright? So, that's our first step. Then, next step, step 2, we're going to convert coulombs to Faradays. So, 1 Faraday is equal to 96,500 coulombs. Therefore, X Faradays is going to be equal to 9,000 coulombs. How we're going to find X? We have to cross multiply. Okay? So top left times lower right, upper right times lower left. So X is going to be 9,000 divided by 96,500. And that is going to give us 0.1 Faradays. As a matter of fact, let's use it to 2 decimal places, 0.09 Faradays. Okay? Work with more decimal places for a greater degree of accuracy. So, Now we have our current now we have our charge that's flowing, and that charge is in Faradays. So the next thing we have to do now is we're going to write our half equation, because the half equation is what is going to set up the third law. Not the third law, oh my goodness. The half equation is what is going to set up the second law. So we're going to write the balanced half equation. Alright, so we're dealing with copper, so it's going to be Cu2 plus ions gaining 2 moles of electrons to form copper. Based on the second law, the simplified way I encourage you to think about it, based on the CXC syllabus, I've never seen them ask a student to state any of the Faraday's laws. So the simplest way to think about it is, however many number of moles of electrons that you have, that is what tells you the number of Faradays that you have. So right now, you have 1 mole of copper ions reacting with 2 moles of electrons to form 1 mole of copper. That means, based on Faraday's law, Faraday's second law, we have 2 Faradays, and those 2 Faradays are giving us 1 mole of copper. But based on our question, based on the amount of current that we use, and based on the length of time, the charge that we have is not 2 Faradays. The value that we have is 0.09 Faradays. So what that means is that if 2 Faradays give us 1 mole of copper, then 0.09 Faradays is going to give us X moles of copper. And then again, we're finding X. All we have to do is cross multiply. Okay? So X is going to be equal to what? 0.09 divided by 2. Yes? And that is going to be 0.045 moles of copper. Once we have the moles, then we can use that number of moles to find out just about anything. We can use it to find mass, which is what we're doing now. We can use it to find volume as well if we were dealing with something that is a gaseous reactant. Granted, we can also find mass of gas, but we can use moles to find mass, we can use moles to find volume. Alright, so our last part of the question now, we have 1 mole of copper has a mass equal to 64 grams. Therefore, 0.045 mole is going to be equal to X grams. And again, all we're doing is cross multiplying. So 64 times 0.045, and that gives us a value of 2.93 grams of copper. So if we look at if we were to create our little electrolytic cell, what we would have is a situation where on our cathode you would start to see a pink solid forming around the electrode. And since we're dealing with a molten electrolyte, As that solid forms, it will start to melt and drip off, and a total of 2.93, almost 3 grams of copper is going to be formed on that electrode.